I'll put the link in the chat in just a second. Mute that. Share this. Alright, so this is the link if you wanted to watch it on YouTube Live. If you're on a Chromebook, I don't believe it's going to work. But if you have like an iPad or something, you can watch that. And what's really cool is that when you guys talk to me, it will send the audio to YouTube. Let me just make sure. Audio's set correctly. So I think this is the one that the audio is weird. There we go. Alright, was anybody able to access it on their Chromebook? Yeah, I didn't think. Alright. Oh, it's got noise suppression and everything. Cool. Oh my goodness. Yeah, I really need to upgrade this thing. Microphone. There we go. Okay, so you guys should be able to hear me. Is anybody able to access the live? If not, then that's fine. All right, so if we go to the study guide, part of them, like some of the questions are going to be set up in a way that the questions are going to be different for each person, and we're going to skip those for now. Let me get Manny. Who else came in? So Frank's in here. Corey just popped in. All right. All right, so Corey or Manny, if you guys are on your own personal computers, can somebody share that link while I'm trying to update the attendance? So I'm actually live streaming on YouTube Live right now. So, okay. If you're on your Chromebook, it's not going to work. But I'm going to try my best to see if they can give y'all access to YouTube Live. Because the quality is just night and day. Where'd Manny go? There he is. Alright, Angela, I see you here. Yep. Brandon, it's not. Jalen, nope. Louis, nope. Trayon, where it goes. Okay. Jordy's not. Okay. So, for you guys that came in late, we are going over the study guide that I posted last night. So the assessment is going to be, what's today? Tuesday? It's Thursday. So I'm going to try to get through everything today. And then you guys have 10 attempts on the study guide. The study guide's not going to be a grade. But you have 10 attempts to get familiarized with it. So anything that is on the study guide is fair game on the assessment. Everything that's on the assessment is going to be on here. So there's not going to be anything that's on the assessment that is not on here. Does that make sense? I don't like to... I don't like to throw any curveballs. So I like to make it as straightforward as possible. Alright. So we're going to go through the study guide and see if you guys have any questions. Get rid of that. Alright. Get rid of my face. There we go. Alrighty. So... you can't see which vid. Which video? Which video are you talking about, Janice? Oh, the live, yeah. So, the one on YouTube, it's exactly what I'm doing here in the Google Meet. But if you have your phone or something, or like a tablet, it might be easier to see, or it's gonna be sharper than what the Google Meet's doing. All right, so this is a velocity versus time graph, like we've done before, but in this case, I changed the color. I don't know if that is better for you guys or not. I think it pops out a little bit more, and it's the same thing that we did last week. Okay, so you're gonna have the drop down menu, and then you choose if it's increasing, decreasing, staying constant, zero, and all that. All right. So if we start off with position, in order to figure out what the position is doing, like how I'm changing my position as time goes on, so from time 0 to time 1, this is above the x-axis. So that means that I'm going to be increasing my position. Because I have a positive velocity, I'm going to be going in the positive direction with my change in position. So I'm going to select positive. Okay? So anything, any of the colors, like any of the colored, the shaded area, if that's above the x-axis, it's going to be positive. If it's below the x-axis, it's going to be negative. Okay? So time 1, time 2, this is going to be positive. Time 2, time 3, that's also going to be positive. And then time 3 to time 4, let's be negative. And then time 4 to time 5, that's going to be negative. Because these 3 are on top of the x-axis, and then these 2 are below the x-axis. Is there any confusion with that? Is everybody good with that? Okay.
Yeah.
Alrighty. So, when it comes to velocity, I look at where my function, and this should have been a different color, the line for the function. I look where my function intersects my time interval. So my vertical line for 0 seconds, my vertical line for 1 second, I want to see what the y value is of my function at that point. So my y value at time equals 0 is going to be 0 meters per second. And my y value when I'm at 1 second is going to be 90 meters per second. So I started at 0, I increased to 90, so I am increasing in that time interval. 90 to 90, I am remaining constant. 90 down to 0, I am decreasing. 0 to negative 90, I am decreasing. And then negative 90 to 0, I am increasing. So any questions about that? Should be pretty straightforward. All right, so for acceleration, all I have to do is I look at the slope. So this slope here from 0 to 1, it's a positive slope. So I'm going to put positive there. From 1 to 2, is it positive, negative, or 0 slope? It's going to be 0. Because there's no rise as I go across for my run. So that means that this slope is 0. In this case, it's a negative slope, and then positive slope. So negative, and positive. Everybody cool with that?
Yeah.
Okay. All right. Lastly, the area. So now that we all pretty much understand how to do these graphs, like we've done them a while, like more than once, and we have a pretty good handle on what to do with it, I want to kind of explain what on earth finding the area is. Okay? So to kind of put it in a nice little package, if I look for the area in between my function and the horizontal axis, that's telling me, or if I do that for the velocity versus time graph, the area beneath the curve, or in between the curve and the x-axis, that's telling me what my position is doing in that time interval. Okay? So in this first situation, I'm going from 0 meters per second to 90 meters per second in 1 second. So I'm going to be speeding up in that time interval. So in order to figure out how far I traveled in that time interval, I have to find the area. So the area of this shape in between 0 and 1 and in between my velocity function and my horizontal axis is a triangle. So the area of a triangle is 1/2 times base times the height. The base in this case, from 0 to 1, the difference between 0 and 1 is just 1 second. The height is going to be 90 meters per second. So 90 times 1 is just going to be 90. And then I multiply that by 1/2 and I get 45. So I traveled a distance of 45 meters in that 1 second. And the quick little trick that I showed you guys, if it's a triangle on a graph that I've given you, I typically use the 1 second time intervals. The base is always going to be 1, so all I have to do is look at the height of the shape, and if it's a triangle, I divide it by 2. And that'll give me the distance. Like the distance traveled in that time interval. So from time 1 to time 2, this is a rectangle, and like what Frank just put in the chat, this is going to be base times height. So the base again is 1 second. The height this time is 90 meters per second. And because it's a rectangle, I don't need to multiply it by 1/2. I just do the base times the height. So 1 times 90, and I get 90 meters positive. This is the same area as the first time interval. It's just flipped. So this is also going to be positive 45. And then if I look at these two, these are both triangles with the same base and the same height. And the height in this situation is negative 90. So if it's a triangle with a base of 1, I just look at the height and I divide it by 2. Negative 90 divided by 2 is negative 45. And that's going to be true for both these two cases here. So negative 45 and negative 45. Alright. So, when it comes to the distance and the displacement, the distance, I add all of these areas up as if they were all positive. Okay? Distance does not care about direction. It's a scalar quantity. Okay? So, the negative that I have for this and for this, that's telling me that I'm going 45 meters backwards. Okay? So, the distance doesn't care about that. It just cares that I went 45. So I just add up all the magnitudes, all the values. So I have 45, and then I'm going to add this 45, so that gives me 90. If I take that 90 and I add this 90, I get 180. And then I just do the magnitudes. These two added together is another 90. So 180 plus 90, I get a total of 270. Hopefully everybody's tracking so far. Okay. So when it comes to the displacement is a vector quantity, so it does care about the direction. So in the first 3 time intervals, I've traveled a total distance of 180 meters. So the first 3 seconds, I went 180 meters, and then my velocity comes back down to 0. I throw my vehicle, or I start walking backwards, and I go this distance. Okay? So it's going to be 180 minus whatever these two added up to be. And if we look down here, it's going to be a negative 90. So it's going to be 180 minus 90. And that would give us 90 meters in the forward direction. Any questions about that? I apologize about the dog. When the bird starts making a lot of noise, the dog doesn't like it, so she starts whining. Alright. Everybody good so far? Any questions at all? Alright. So, how do I figure out the velocity of this graph? Like, what's the velocity doing during 0 seconds to 25 seconds? How do I figure out the velocity? Anybody know? Let me show you. Distance over time. So, in the time interval from 0 to 25, I went a distance of 50 meters. So I do my distance traveled. I went from 0 to 50 in the time of 25 seconds. So 50 divided by 25, I get a positive 2 meters per second. Now, with this one, I want to remind you guys what the equation is for velocity. So velocity, because it's a vector, it does need the direction. Velocity is going to be my change in position over my change in time. So my change in time, we already know, is 25 seconds. But to make sure that we get the signs correct, we have to do this. My final position minus my initial position over my change in time. Remember, delta x is just my change in position, so it's going to be my final minus my initial. So if I go back to the problem in just a second. If I go back here, I start my position at 50 meters. So that's my initial position. My final position is 0. So my final position was 0 meters. My initial position let's do 0. My initial position was 50. And then this was 25 seconds. So 0 minus 50, I get a negative 50 divided by 25. And that gives me negative 2 meters per second. Okay? And we know that it's negative because if I'm starting at 50 and I'm going down to 0, I'm traveling in the negative direction. It's going to be negative 2 meters per second. So this is the same graph as the previous question. And this one is asking, choose the correct velocity versus time graph for what we just found. Okay? So we just found that it was negative 2 meters per second. Which one of these graphs shows a velocity of negative 2 meters per second? This could be graph 1, 2, 3, 4, or 5. Gotta give me some feedback, guys. I know it's right after lunch. Anybody at all? So this is my position versus time graph. The same one as we did in the last question. We found that our velocity is negative 2 meters per second. That's what we found here, negative 2 meters per second. So which one of these graphs shows me the graph of negative 2 meters per second? Which ones can we automatically knock out? We can knock out number 3 and number 5 because in those two graphs, my velocity is changing. And that's not the case for this graph. So what's wrong with number 2? What is it saying that my velocity is? My velocity is 0 here, so that's not right. My velocity in this case is positive 2, but like we said, we want negative 2. So that's why number 4 is the correct answer. Cool? Any questions? Okay. So, in this problem here, in this graph, we know that from time 0 to time 25 seconds, I'm going to be increasing my position. Okay? The y value is going up as my x value increases. So as I go along here, I'm going up in value. So my position is going up as time goes up. So I need to have a positive velocity in this time interval. So let's see what we are given. So I need a positive velocity in the first section. So this one is out because my velocity is 0. That doesn't track. This one could be it. This one could be it. That one could be it. This one's negative, so that doesn't count. And this one's negative. So it's either going to be 2, 3, or 4. Okay? So let's figure out what's happening in the second time interval. I go from 25 seconds to 50 seconds, but my position does not change. So if my position doesn't change, do I have a velocity? What's my velocity right now? My velocity. My velocity is 0, right? Because I'm not changing position. So we need to have something that's positive and then something that's 0. So I'm not even worrying about the values at the moment. So out of these 3 that were left, 2, 3, and 4, I need something that was positive. But then in the second time interval, I needed something that was 0. So this would be the only option that would work. Does that make sense? Now, if there was one that was like this, or let's say if this one, this part was on the horizontal axis, in order to figure out if it was 1 meter per second or 2 meters per second in that first part, again, I take my, at this time of 25 seconds, I travel 25 meters. So it's 25 meters over 25 seconds, and that reduces down to 1 meter per second. So this is definitely the answer. So I'm going to go with graph number 2. Oh, yeah. So, yeah, you said it was number 2 before, Louise. All right. Okay, so these ones are going to be different for each person. So I'm going to skip these for now, because I want to make sure I get to the other ones that are going to be all the same. So I'm going to skip this one, skip that one. Okay. So with this, you can select multiples. Okay. So which of the following are units of length? Is meter a length? Yes. Kilometer? Yep. Seconds? Nope. Inch? Yep. Foot? Mm-hmm. Kilogram? Nope. Gram? Nope. And hour? Nope. All right. Sakura, you're dropping the ball. All right. So, mass and weight are considered to be the same thing. Is that true or false? Sakura, why is it false? Are you able to unmute and explain?
I think like one is more related about gravity, and the other one is more related about like the actual object, like the atoms in the object, or something like that.
Okay, yeah, you're on the right track. So, when we talk about mass versus weight, mass is the amount of matter that an object has. Okay. And weight is the force that gravity is pulling on an object's mass. So this is the force due to gravitational acceleration. Okay. So when it comes to, if I was, well, no, never mind. There's a question about this. So mass is just the amount of matter, and weight is just a measure of how much the gravity is pulling on that mass. Does that make sense? Give me 1 second. My come on, my phone. I thought I had put it on Do Not Disturb. There we go. Apologize about that. Go back to here. Okay. So mass and weight are considered the same thing. That is a false statement. All right. So, if Mr. Applewhite stepped on a scale in the United States and got a value of 180 pounds, what would the scale read on the moon? Would it be higher, lower, or would it read the same? It would be lower. The reason why is because the acceleration due to gravity on the moon is a lower value than it is on the Earth. So we're going to go with lower. So if I step on the scale in Great Britain and I got a value of 82 kilograms, how would this scale read on the moon? Oh, I did not change the values. Dang it. That should be 82 kilograms. 82 kilograms. Read the same kilograms. So would it be higher, lower, or read the same if I was measured in kilograms? Manny, what do you think? Corey, what do you think? So, kilograms is a measurement of mass, and if I go from the Earth to the moon, assuming I'm not losing an arm or a leg, I'm going to retain my mass. Oh, it's a rare event that I mess up. Oh, well, so I was more focused on, you're talking about the problem, like right here? Yeah. I was more focused on getting the other stuff in, and this was after the call that I had with Dr. Romig. I'll talk to you guys about that later. So I would read the same kilograms. So I'll go back and fix that. All right. So how would you describe the velocity of this woman in this picture? Is she speeding up, slowing down, or is she traveling at a constant speed? Yes, in the previous question, it's the same because it's in kilograms, because that's a measurement of mass, not weight. Manny, what do you think she's doing here? Is she speeding up, slowing down, or traveling at a constant speed? She's speeding up. What do you think that, Alberto? Why is she speeding up? If you guys remember a couple classes ago, the amount of distance from each time interval, the amount of distance covered per time interval, if it's the same, then I'm traveling at a constant speed. If each time interval goes by and my distance between the pictures gets smaller and smaller, I'm slowing down. But in this case, every picture, the distance is getting bigger and bigger, so she's speeding up. She's covering more distance in the same time interval. So in this situation, she is indeed speeding up. Good. All right. Don't make fun of her legs. If an object is moving to the left and each black dot represents 1 second time interval, how would you describe the motion of this black dot? The options are speeding up, slowing down, or a constant velocity. Correct. It is slowing down. The distance between these two dots is larger than these two, which is larger than these two. So as time progresses for each different dot, the distance between the dots is smaller. So this dot is actually slowing down. Okay. So if snapshots were taken every 2 seconds, how far has the dot moved after 2 seconds? Correct, 1 meter. So at 0 seconds, I'm at 0 meters. After 2 seconds, I'm at 1 meter. Pretty simple. So I'm pretty proud about this. I'm proud of this. This I made myself. What do y'all think? It's kind of laggy. Why is it so laggy? Is it smooth on y'all's end? Or is it kind of jumping? Dang it. It's smooth on my end. That's frustrating. It'll be smooth on y'all's. Like when y'all pull it up, it'll be good. Alright. So I want to know, what is the distance traveled? So from time 0 to time 1, how far did I travel? 150 meters. And then from time 1 to time 2, what's the difference between 150 meters and 50 meters? We went another 100 meters. So it's 150 plus another 100 plus from 50 to 200, that's another 150. So we went a total of 400. Does that make sense? 150 for that trip, 100 there, and then another 150 that way. So 150 plus 100 plus another 150. I get 400. Now, don't think too hard about this one. What is my displacement? Good. It is 200. So I can look at that as from time 0 to my final time, I went a distance of 200. But if I also do this, if I go from 0 to 150, I subtract 100, and then I add 150, I would also get 200. Cool. Are you saying that I'm boring, Sakura? Is that what you mean? Oh. Okay. Alright. That's right, Angel left. Alright. So, if I go back to the unit conversion problems. Yeah, you guys can... You're not supposed to be... Y'all could be following along if you wanted to. But as long as you guys are paying attention, you should be able to go through the study guide after this on your own and understand it. As long as you're asking questions if you don't understand something while I'm talking. But you're all good right now, right, Jade? Everything making sense? Y'all good, Jade? Like everything so far is good? No, this is not a grade. I just have the point values on there just for whatever reasons. Okay. So I'm assuming everybody's good. So, do I need to go over unit conversions? I know it's been a little while since we've done it. And the unit conversions that I'm going to give you are just going to be in the metric system. Okay? So I'm not going to make you guys do any converting from different unit systems, like the English or Imperial into metric. Can you call me APW for short? Sure. Kids my first year called me A-dubs. Alright, so let's just do this one real quick. Alright, so 3,392 centimeters. 3,392 centimeters. And I want to convert that into meter. Okay. So when we're given a unit conversion problem, I need to figure out how can I get from centimeter into meter. And I try to think of my formula sheet, which you guys are allowed to have, but I want to make sure that you guys know where it's at. Oh, come on. Why is it downloaded? I just want to look at it. Oh, that's nice. Alright, I'm going to switch back to over here. So, this is the document that is on the announcement for the study guide. So these are the conversion factors that we can use. So I want to go from centimeter to meter. And I don't think it's on there. Yeah. So these ones are going from US to metric. But you guys should know how many centimeters are in a meter. Do you guys know that? Back over here. There we go. So yeah, there are 100 centimeters. So think about like a century. A century is 100 years. So there are 100 centimeters in 1 meter. So my conversion factor that goes from centimeter to meter or meter to centimeter is going to be 100 centimeters equals 1 meter. Cool. So that's my conversion factor. Now, what I've taught you guys is when we're doing these conversions, I write down the given value and the given unit. And let's do this in red. And then for every conversion factor that we have, we're going to create a scaffold. So it's just a multiplication symbol, or multiplication dot, a fraction bar, and then I go ahead and I put my parentheses on top and bottom. So if I need to get rid of my centimeter, centimeter needs to be in the denominator. So I'm going to put centimeter here, and if centimeter is there, that means that meter needs to go right there. And then I put the numbers with the unit. So the 100 goes with the centimeter and the 1 goes with the meter. After that, I like to take my values and my units and separate them, just as a way to double check and make sure that my units cancel properly. So these are my values. And I have my units over here. So I have centimeter, meter, and centimeter. And before I do anything with the numbers over here, I'm just gonna once again check and make sure that the value or the unit that I'm looking for is the only one that's left, and that is the case. So now I'm allowed to do this. So multiplying anything by 1 doesn't do anything. So all it's going to do is just going to be 3,392 divided by 100. And what's nice about the metric system is all I have to do if I'm dividing by 100 is I'm going to move my decimal 2 points to the left, or 2 jumps to the left. Okay? So that will give me 33.92 meters. Any questions? So 33. Oop. The wrong button. 33.92. All right. So how many centimeters or how many millimeters are in a centimeter? You guys know this offhand? focus. So that is one right here. Oh, where's my little arrow? There it is. So, I'm trying to do this backwards. Come on. So, that thing that looks like a 10, that's 10 millimeters. And that's actually going to be 1 centimeter. So every 10 centimeter, or 10 millimeters, I get 1 centimeter. Cool. So 10 millimeters equals 1 centimeter. So if I have this many centimeters, and for every one of these centimeters I have 10 of these millimeters, I only have to just multiply this by 10. And if I just multiply by 10, I just move this decimal to the right. So what I'm going to end up getting is be 947.3. All right, so I've got meter into kilometer. So I have a whole bunch of the smaller units, and I want to go to a much bigger unit. So is my magnitude going to get bigger or smaller? If I have a bunch of little units and I want to know how many of the big units it is my value going to go up or down? My magnitude should go down. So for every 1,000 meters, I have 1 kilometer. So 1,000 meters, I have 1 kilometer. So I've got 3,000. So I should have at least 3 kilometers. And then after that, it's just part of a kilometer. So if I'm going from a small unit to a big unit, I divide. Okay? So I'm going to be dividing this by 1,000. So my decimal point is here after the 8. And if I'm dividing, I go to the left. And since 1,000 has 3 zeros in it, I go 1 jump, 2 jumps, 3 jumps. So 3.358 kilometers. All right. So if there were 10 millimeters for every centimeter, that means that there's 1,000 millimeters in a meter. So I'm going from 1 meter, and then I'm going into a smaller unit, so my value is going to go up. So I've got almost 2 meters. And since the conversion factor is 1 meter is equal to 1,000 millimeters, I'm going to be multiplying by 1,000. Or I can just move the decimal point 3 times to the right. So I get 1,994 millimeters. So there's 10 centimeters or 10 millimeters for every centimeter. So for every 10 millimeters, I get 1 centimeter. So I'm just going to move the decimal to the left. And I think I got 2 more questions and then we're done. All right. So millimeter and meter again. So there's 1,000 of these guys inside of a meter. My decimal point is right here after the 0. and I'm going to be dividing this by 1,000. It's going to be 48.56 meters. And last question. There is 100 centimeters for every meter. I'm going from a big unit to a small unit, so I'm multiplying. So my value is going to get bigger. So I'm going to have 14,000. 14,205. Okay, and that should be all the questions. Let's see how we did. What? I knew that was messed up. Alright. I saw a whole bunch of different weird ones in there. Let me go back and fix that. I'm glad I caught that. Everything else was good. Okay, cool. Alright, any questions? Everybody good? Alright, I'm going to stop the broadcast now.